Hi and welcome back to the Core Learning channel. Today I'm going to be going through the November 2022 Maths GCSE Higher Tier Paper 3, which is the Calculator Allowed paper. I'll be going through each question and show the methods I use to approach each question. So if you haven't already, please hit that like button and subscribe to our channel. This really helps us grow and reach more people, so your support really does help. Plus, if enough of you subscribe, I might actually get paid to do this. And with that, let's jump into our questions. So, starting with question 1, and we have 2 to the power of x equals 32. What is x? So, if we work this out, we have 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32. So we can see there we have 5 lots of 2, so that's 2 to the power of 5. So x is 5. Moving on to question 2, and we're asked what is 1.8 times 10 to the power of minus 4 as an ordinary number. So the way we do this is whatever the number here is, this is how many zeros we write. So 0.000, so we have 4 zeros and then 1/8. So question 3, and we're given this expression 6x squared times x cubed plus 2, and we're asked to expand the brackets. So here we just multiply each term on the outside with the terms on the inside. So we have 6x squared times x cubed. So we have, we're combining powers here. So because it's a multiplication, i.e. 6x squared times x cubed, what we do here is we add the exponents. So this becomes 6x to the power of 2 plus 3, which is 5. And then this is going to be plus 6x squared times 2, which is 12x squared. And this is our final answer. So moving on to question 4, and we're told that x is greater than 30 and less than 300. And we're also given this piece of information that x is 200% of y. Now the key thing to note here is what this means is that x is 2y. So what this means is that y is half of x, and therefore we just need to divide each of the inequalities by 2. So we have that y is greater than 15 and less than 150. So moving on to question 5, and we're given that ABCDE is a pentagon. So let me just draw this out quickly. I'm just going to label these sides DE. And what we're asked to do is work out the area of this total pentagon ABCDE. Now, what we can do here is we can recognize that this shape here is a trapezium. So I'm just going to label that trapezium. And obviously here, we have a right angle triangle, which I'm just going to call triangle. So to work out the total area, I'm going to add the area of the trapezium to the area of the triangle. So let's just have a look what values we're dealing with. So we have 20 centimeters between B and C. We have a height of 11 centimeters. We have 14 centimeters between A and C. We have 10 centimeters on this side, and we have 7 centimeters on this side. So what I'm going to quickly do, just as an aside, I'm just going to go over how we work out the area of a trapezium. So to do that, because we need to work out what the area is. So if I have a trapezium here, what I'm going to do is I'm going to split this into 3 sections. So I can split this into a right angle triangle here on this side. I can split this side into a right angle triangle. And I'm going to label these areas 1, 2, and 3. And what I'm going to do also is label the top as A, and therefore this bottom part as A. And then this whole width I'm going to label as B, and then we have a height of H, and I think we're good to go. So the area of this trapezium is going to be area 1 plus area 2 plus area 3. So area 1 is going to be given by, and sorry, this is X, so X is here. So area 1 is going to be given by X times H over 2. Area 2 is just a rectangle, so this is going to be A times H. Let me just go up there. And area 3 is going to be, again, it's a right angle triangle, so in this case, it's going to be, and I forgot to label this side, I'll call this side Y. So this side is going to be Y times H over 2. And the total area is going to be, so I call this area total, is going to be areas 1 plus 2 plus 3. Okay? So let's substitute in the values we have. So we have area 1, so we have X times H over 2 plus A times H plus Y times H over 2. And let's scroll up. And now, one thing to bear in mind, if we look, X plus A plus Y is equal to B. So let's make a note of that. And we'll just hang on to that as we go through this. So now that we have this, we can factorize the above expression. So this area total is equal to, and in fact, let me just make a note of that in case that's not clear. So area total So what we can do here is take out a factor of H over 2, and now we have an X plus 2A. We can see it's 2A because if we have 2A times H over 2, the 2's cancel and we just get H times A, plus Y. But we can simplify this further because we've just said that X plus A plus Y equals B. So this is actually equal to H over 2 times A plus B. And this is our total area for a trapezium. Our total area, and this is our total area for a trapezium. So now that we have this, and we also know that A equals 14 centimeters, B equals 20 centimeters, and H equals 11 centimeters, we can plug this in to find the area of the trapezium. So I'm just going to call this area trap, and this equals H over 2, so that's 11 over 2 times A plus B, that's 14 plus 20. And this equals 187, and this is in centimeters, so it's going to be centimeters squared. And now, if we go back up, we can see that we have the triangle, the right angle triangle attached to this trapezium as well. So to work out the total area, we also need to consider the total area of this right angle triangle. So in this case, the area of the triangle, which I'm going to call area tri, is going to be equal to a half times the base times the height. So I'm just going to draw the triangle quickly. So we've got our right angle here, and we have 7 centimeters, and we have 10 centimeters. And so in this case, our B is going to be 7 centimeters, and we're going to have our height as 10 centimeters. So the area of our triangle is going to be a half times 7 times 10. And don't forget this is in centimeters. So this is going to be 35 centimeters squared. So the area total is going to be the area of the trapezium plus the area of the triangle, which is equal to 187 centimeters squared plus 35 centimeters squared. and this equals 222 centimetres squared. So moving on to question 6, and we're told that Joe, Kim and Lisa each have an amount of money and that Joe has £72. And we're told that Joe's amount compared to Kim's amount is in the ratio 6:5, and that Lisa's amount is 1.5 times Joe's amount. So let's write this out in the form of some equations. So we're going to call Joe J, and Joe has £72. We know that the ratio J to K, this is Joe to Kim, is 6:5. And we know that Lisa has 1.5 times Joe's amount. So Lisa equals 1.5 times Joe. So immediately we can work out what Lisa's amount is. So Lisa's amount equals 1.5 times 72, which equals £108. And then we just need to work out what Kim's amount is. So if we know that J to K equals 6:5, then what we're trying to say is, what is this as 72 to X? Well, in this case, we're saying 6:5 equals 72 to X. Therefore, X equals 72 over 6 times 5. So X equals, 72 over 6 is 12, times 5 is 60. So this means that Kim has £60. So the total is J plus K plus L, and this equals £72 plus £60 plus £108. And this added up gives us £240, which is less than £250. So moving on to question 7, and we're told that a rule has the sequence that after the first 2 terms, each term is the sum of the previous 2 terms. And we're told the following. So we're told, and these are the terms in our sequence, and so I'm going to call the sequence values A. So we're told that the first term is 33. We're told the second term is X. We're told the fourth term is 73. And we want to work out the value of X. So what I'm going to do here is I'm going to call this third term Y. And what I'm going to do is I'm going to say that I know that Y is equal to 33 plus X, because we're told after the first 2 terms, the next term is the sum of the previous 2 terms. So I know that Y is equal to 33 plus X. I also know that 73, which is the fourth term, is equal to X plus Y. So now I can say that X equals 73 minus Y, and I'm now going to use this to work out the value of Y. So I have that Y is equal to 33 plus, and I'm going to substitute this value of X in here. So I have Y is equal to 106 minus Y. And this gives me that 2Y is equal to 106, and therefore Y is equal to 106 over 2, which is 53. Using this information now, and I can use my other equation, which says that X equals 73 minus Y. Well, I now know what Y is, so I can substitute this value in. So X is equal to 73 minus 53, which equals 20. Moving on to part B. An expression for the nth term of a different sequence is n minus n squared. So I'll just make a note of that. And Ruth says all the terms will be negative because n squared is always greater than n. Is she correct? In this case, she will not be correct. And the reason for this is because if we take the case when n is 1, we get 1 minus 1 squared is equal to 1 minus 1, which equals 0. And 0 is not negative. So moving on to question 8. and we're given some information about members of clubs A and B. So for club A, the number of members is 24 and the mean height of members is 1.8 meters. And for club B, there are 20 members and the mean height is 1.92 meters. So, and it's asking us to work out the total height of the members of club A over the total height of the members of club B. So if we think about what we're talking about when we talk about the mean height, well, let's call it X bar. So this is the mean height of a group. It's represented by the height of each member. So let's call this height A plus the height of person B plus and so on to the height of person N, where N is the number of people in our group, and we divide this by N. Another way we can write this is mean equals total height over number of people. So the total height of a group is given by the mean times the number of people, which I'm just going to call N. So in this case, for club A, the height total, which I'm going to call H of T, is equal to the mean, which is 1.8 meters, times the number of people, which is 24. So in this case, this is going to give us 43.2 meters. And we do the same again for club B. So for club B, we have the height total is equal to the mean height, which is 1.92 meters, times the number of people, which is 20. And this gives us 38.4. So then the ratio between them, so the ratio of club A to club B is going to be 43.2 over 38.4. And we could include the units, but they're just going to cancel out. And this gives us a value of 1.125. So moving on to question 9, and we're told that P and Q are points. We're told the x-coordinate of Q is 4 more than the x-coordinate of P, and the y-coordinate of Q is 5 less than the y-coordinate of P. We want to work out the gradient. So the way we're going to do this, let's write out our coordinates. So I'm going to say that P has coordinates Px and Py, and Q has the coordinates, well, we've said here that for Q, the x-coordinate is 4 more than the x-coordinate of P. So we can say that this is equal to P of x plus 4. And then likewise, we can say the y-coordinate is P of y minus 5. And now to work out the gradient, let's just remember what the gradient is. The gradient is y2 minus y1 over x2 minus x1, where these are obviously our x and y coordinates. And so if we plug those in, well, if we say that our y2 and x2 are going to be the q coordinates, then we'd say, and I'll just label these actually, so in fact that's not correct. So this we're going to say is our x2, and this will be our y2, and this will be our x1 and our y1. And so what we have now is P of y minus 5 minus P of y over, so we have our x2, which is P of x plus 4 minus P of x. So we can see here on the top, we're going to have this P of y and minus P of y cancel, and on the bottom we're going to have this P of x and minus P of x cancel. So our gradient is simply minus 5 over 4, which in decimal form is minus 1.25. So moving on to question 10. Here we're told that the results after 250 spins of a coin, we have 128 heads, 122 tails. And now the coin is spun an extra 50 times, and after all 300 spins, the relative frequency of heads is 0.49. So we want to know for the extra 50 spins what the number of heads to the number of tails ratio was. So what we're going to do here is first work out after 300 goes what the number of heads and tails are. So if we know that the relative frequency of heads is 0.49, then we can just times 300 times 0.49, and this gives us 147 heads. And obviously if we've had 300 turns, then the number of tails is going to be 300 minus 147. So 300 minus 147 equals 153 tails. So if we know that the final tally, is for heads to tails 147 to 153, and after 250 spins was 128 to 122, then the ratio in between this period is obviously just going to be 147 minus 128 to 153 minus 122, which is 19 heads to 31 tails. Moving on to question 11. So here we have part of a running track is the arc of a semicircle joined to a straight line. We're told the semicircle has diameter 45 meters and the straight line has length 75 meters. We're told Abby runs once along this part of the track in 18 seconds and we want to know her average speed. So what we want to know first is going to be the total distance. And this is going to be equal to the initial straight part, which is easy, that's just 75 meters, plus the length of this arc. And the length of this arc is going to be given by, well, the circumference of a circle is 2 pi r, or pi times the diameter. So, the circumference of a circle is pi times the diameter. But in this case, we only have half of a circle. So in this case, it's going to be pi times the diameter over 2. So it's going to be pi d over 2, where d is the diameter. And so if we know that d is equal to 45 meters, then this is going to be equal to 75 meters plus 22.5 pi. And this gives us a value of 145.69 meters. So now that we know this, the speed is given by a distance over time, where we know that her time is 18 seconds. So this is going to be 145.69 meters over 18 seconds, which gives us 8.09 meters per second. So moving on to question 12, and we're given two triangles ABC and DEF, and we want the single transformation that shows they are congruent. So congruent here just means that they're the same shape. So what we can do here is, if we map the coordinates from each triangle to their corresponding coordinate, we can find a translation for one of those pairs, and then if it's congruent, the same translation should apply to the other pairs as well. So what do I mean by this? Well, let's take A and D. So these are the tips of each triangle. Now, if I want to go from A to D, then you can see in the x direction, I need to go from an x coordinate of -4 to an x coordinate of 2. So this is going to be a translation, because we're just moving it, we're not resizing it or rotating it. So there's going to be a translation, and for the x coordinate, it's +6. And then for the y coordinate, we can see that A has a y coordinate of 1 and D has a y coordinate of 5. So we'd have to go up 4 in the y direction. Now, let's just check each of the other pairs of coordinates to see if this works. So let's take point B, and we want to get to point E. So if we start from point B, B has an x coordinate of -5, and we want to get to 1, which is the x coordinate of E. So, yep, that's a +6 translation in the x direction. And then B has a y coordinate of -3 and E has a y coordinate of 1. So we need a y translation of +4. So the translation works for point B to E. And then for point C to F, C has an x coordinate of C has an x coordinate of -2 and F has an x coordinate of 6. So we can see this is a translation of 6 in the x direction, and C has a y coordinate of -3 and F has a y coordinate of 1, so this is a +4 translation. So the shapes are congruent because that translation of 6, 4 works for each pair of corresponding points. So moving on to question 13, and we're told that a fair ordinary dice is rolled and a counter is taken at random from a bag, and we're given the probabilities here. So the first question says, how do the probabilities show that all the counters in the bag are red, blue, or green? Well, that's simple. Let's just add the probabilities of each one. So we've got red, which has a probability of 0.1. We have blue, which has a probability of 0.3. And we have green, which has a probability of 0.6. So if we add all those together, we get 1. So 1 is the highest we can have. So this shows that there are only red, blue, and green in the bag. So moving on to part B, and we're told to circle the probability that the counter is red or blue. So in this case, what we need to do is we first roll the dice. So we have 0.5 if it's an even number, and then we have 0.5 times 0.4, because this is the probability of red or blue. And then we need to go the other way on the branch, so we add, and again, if we roll an odd number, this is again a 0.5 probability times, and again, it's the probability of red or blue, which is the two probabilities added, which is 0.4. And this gives us 0.4. So moving on to part C, and we're told to circle the probability that the dice lands on an even number and the counter is blue. So here we have the probability of even and blue. So we just multiply the probabilities. So even has a probability of 0.5 and blue has a probability of 0.3, which gives us a total probability of 0.15. And this is our answer. So moving on to question 14. And we're given two solid cubes, x and y, and we're given the mass of x and told the area of each face of x. And we want to know the density of y, assuming that y is identical to x. So what density should we get for y? So let's just draw out our problem here. So we've got our cube, and this is x. So let's just call this side here a of x, and we're going to call this side here b of x. And we're told that the area of each face of x is 784 centimeters squared, which means a of x times b of x is 784 centimeters squared. And obviously here, because we're assuming it's a cube, then a of x should equal b of x. And hence, this means that we have a squared equals 784 centimeters squared. And so we can work out one of the sides of the cube. So we have, I should put next here. So we've got a of x is equal to, well, we can just take the square root of both sides. So we have square root of 784, which is 28 centimeters, because it's just a length. So now we have one of the sides of x. So what we're assuming here is we're saying if x and y are identical, then what we take that to mean is, in fact, no. What this means is the mass of x is equal to the mass of y, and the length of the sides of x is equal to the length of the sides of y. Now, we're asked here about the density of y. So let's just remember what the density is. The density is given by mass over volume. Okay. So for y here, we can say this is equal to the mass of y, which we remember we're saying the mass of y is equal to the mass of x. So we've got mass of y over one of the sides of y, cubed, because remember the volume of a cube is one of the lengths multiplied by itself 3 times. So we're told that the mass of x is 10 point, and I'll just write this out, sorry. The mass of x is 10.976 kilograms. So we can assume that the mass of y is the same. So we have 10.976 kilograms over, and then this is going to be, we can assume that the length of y is the same as the length of x, which if you remember was 28 centimeters. So we have 28 centimeters, but this is cubed. So remember to cube your units as well. So this is going to be in centimeters cubed. Now, what I want to do is also work this out in terms of grams per cubic centimeter. So my volume is in centimeters cubed, but you can see that my mass is in kilograms. So let me just rewrite 10.976 kilograms in grams. So to do this, we have to times by 1,000 because 1 kilogram is 1,000 grams. So if we times, and in fact, actually, I don't need this. So if we have 10.976 times 1,000, this gives us 10,976 grams. So now we're ready to work out the density of y in terms of grams per centimeters cubed. So this gives us 10,976 grams over, and 28 cubed is 21,952 centimeters cubed. So this gives us a value, when we work this out, of 0.5 grams per centimeter cubed. So moving on to part B, and we're told that the mass of y is less than the mass of x, and the area of each face of y is greater than the area of each face of x. So if we say that the density of x is equal to the mass of x over the volume of x, and we say that in the case of y, in fact, and we say in the case of y, it's actually going to be less than m of x for the mass, and for the volume is going to be greater. Well, if we decrease the number on top and increase the number on the bottom, then it means that this value, the density of y, is going to, and in fact I'll put p of y will be smaller. So moving on to question 15, we're told that a mobile phone takes 2 hours to charge from empty, and we're told when the phone is being charged, the current flow into the phone starts at 100%, continues for a period of time, and then gradually decreases until the phone is fully charged. And this is represented across graph A and B. So for part A, we're told that Megan's phone is empty of charge, and she starts charging her phone at 10 a.m. And using graph A, we want to estimate the time when the current flow starts to decrease. So we can see here that this point here is where the current flow is starting to decrease. So if we just take this down, we can see that this is about 26, so 26 minutes. And just be careful reading the question. It's not asking how long, it's asking at what time. So if she started charging at 10 a.m., then if we add the 26 minutes, we get a time of 10:26 a.m. So moving on to part B, and we're told that using graph A and B, we want to estimate the percentage charge in the phone when the current flow is 40%. So using graph A, we can see that the current flow for 40%, if we come across, come down, we can see that the current flow is 40% at the time of 36 minutes. So at 36 minutes, we have 40% current flow, which I'm just going to call CF. So the question now is, what is the charge in the phone after 36 minutes? So if we find 36, let me come up, then we come across, we can see that at 36 minutes, the charge in the phone is 80% charge. So moving on to part C, and we're told that using graph B, estimate the rate of increase in the percentage charge when the phone has 90% charge. So if we first of all just identify 90, and then if we track it across, it's not the best, but there we go. So roughly about at this point here, this is our 90%. So what we want to know here is estimate the rate of increase in the percentage charge when the phone has 90% charge. Well, we can do this by using the gradient, because when we're talking about a rate of increase, we're talking about the change in the charge per unit of time, which we know the gradient is y over x. Well, charging phone is y, charge time is x. And we know gradient is y over x. So if we took the gradient here, it would give us y over x, which is charge in phone percentage over charge time in minutes. So it might be easier if I choose a different color here. So what I'm going to try and do here is draw a line that's tangent to this point. And in fact, I'll just get rid of these other lines just to make it a bit clearer. So let me just... So I'm going to choose this as my line, and I'm going to say this is tangent, as I don't have a ruler, but we can see here this is nice actually, because we have this point here which is at 30, we have this point here which is at 60, and then we can see, yeah, so we have some nice boundaries here. So if we remember, and I'm just going to switch back to black here, if we remember that the gradient, which I'm going to call m, is equal to y2 minus y1 over x2 minus x1. Well, in this case, my x2 is going to be 60, my x1 is going to be 30, my y2 is going to be 100, and my y1 is going to be 80. So I can just substitute these values in. So we've got 100 minus 80 over 60 minus 30 is equal to 20 over 30, which is 2/3. So what we're saying here is at 90% charge, the rate of increase is 2 over 3, and let's just make this clear. This is 2 over 3%. So this is a 2 over 3% increase per minute. So moving on to question 16, and we're told that h is inversely proportional to the cube root of L. So we can write a general formula for this. So h equals, and we're going to say k, which is going to be a constant term that we're going to work out, over, and if it's inversely proportional, remember it's 1 over, so it's going to be k over, and then the cube root of L is L, and I'm just going to write this to the power of a third. And we're told that when h equals 7, L equals 64. So now we can just rearrange to find k. So k equals h times L to the power of a third, which equals 7 times 64 to the power of a third. And 64 to the power of a third is just 4. So this is 7 times 4, which is 28. So our final equation becomes h is equal to 28 over L to the power of a third. Moving on to part B. And we're asked to work out the value of h when L equals 2,744. So h equals 28 over 2,744 to the power of a third. So we just need to work out what 2,744 to the power of a third is. And if we work that on the calculator, we get that that is equal to 14. So h is equal to 2. So moving on to question 17. And we're told that A, B, and C are points on a circle which has the centre O. We're told that BD is tangent to the circle and OCD is a straight line. Right, so I'm going to start out with the most difficult angle to work out here, unless we know the proof. So the most difficult angle to work out is this angle by the origin. So what I'm going to do is do a quick proof to show what this is going to be. And the long and the short of it is, if we go down, if we have this situation here where we have this angle at the circumference A and then this angle at the centre B, we should have that B is equal to twice the angle at the circumference. And I'm going to quickly go over why that is. So what I'm going to do is I'm going to draw a straight line from the origin up to the circumference. And what we know here is, if all these points connect between the circumference and the origin, then I can label each of these with R because these are each the radius. What we then know is that if we have two sides of equal length, then this is an isosceles triangle. And what this means is the angles here and here are going to be the same. So I'm just going to call these angles Y. And likewise on the other side, I'm going to call these two angles X. So what we can say now is, for each of these triangles, so we have this triangle on the left-hand side and this isosceles triangle on the right-hand side. Rather, they're both isosceles triangles, I should say. So what I can say here is that the total angle in a triangle is 180. So we can say that 2x, and then let me just label some other sides. So let me call the angle here C, and then I'm just going to get rid of this origin, and let's call this angle here D. So let's say that 2x plus C equals 180, and let's say that 2y plus D equals 180. And let's just remember that this angle down here is B. So what we can say here, let's say that C, and we're just going to rearrange these, that C equals 180 minus 2x. We're going to say that D equals 180 minus 2y. And we know that C plus D plus B equals 360 degrees, because C plus D plus B is a circle, so there's 360 degrees in a circle. So what we can do now is we're going to substitute these values of C and D in. So we have 180 minus 2x plus 180 minus 2y equals, plus B equals 360 degrees. Let's just simplify this. So we've got 360 minus 2x minus 2y plus B equals 360 degrees. So we've got a 360 on each side, so these just cancel. And if we rearrange, we get that B is equal to 2x plus 2y. But if we look, we can see up here that if we compare our two diagrams, we have x plus y, so this angle x plus angle y is equal to this original angle A. So we have A equals x plus y. Well, for this B, we could say that B is equal to 2 x plus y, which is therefore equal to 2 times A. Therefore, B equals 2A. Right. We've got that out of the way. So we can now say that the angle here is 64 degrees. We're told that BD is a tangent to the line. So if it's tangent to the line and it goes to the centre, this means that the angle here must be 90 degrees. So the angle X is equal to 180 degrees minus 64 degrees minus 90 degrees. And this gives us a final answer of 26 degrees. So moving on to question 18, and we're given 9m plus 4 times 2m minus 1 equals p squared plus pm. And we're told that we want to make m the subject of this. So what I'm going to do first of all is expand everything. So I have 9m plus 8m minus 4 equals p squared plus pm. And now I'm going to try and move all my m terms to one side. So I can simplify on the left-hand side because we have 9m plus 8m, that's just 17m. And then I can subtract pm from both sides. And I get this p squared plus 4 on the other side. So now I can factorize out the m from the left-hand side, and I get m times 17 minus p equals p squared plus 4. And therefore, we can divide both sides by 17 minus p, and we get that m is equal to p squared plus 4 over 17 minus p. So moving on to question 19, and we're told that a circle has centre 0, 0, and passes through the points 0, 11. And we want to write down the equation of the circle. So the equation of a circle is always given by x squared plus y squared equals r squared, where r is just the radius. So in this case, we can see here that if one of the coordinates that it passes through here is 0, then the other one must be the radius. So we know that r is equal to 11, so this is our radius. And therefore, the equation of the circle is just going to be x squared plus y squared equals 11 squared, which equals 121. So moving on to question 20. And we're told that there should be a train leaving a station every hour from 7 a.m. No trains leave early. We're told the probability the first train leaves on time is 0.9, and then for all trains after, if the previous train did not leave on time, the probability that this train does leave on time is 0.8, and that it doesn't is 0.65. So we want to work out the probability that the first 3 trains leave on time. So we can represent this with a tree diagram. So I'm just going to call train 1 T1. And we can just start building this out. So we've got T1 on time, and that's 0.9. And then we've got T1 not on time. And we can branch out from here. So train 2 on time. Well, if the first train is on time, then we're told that the probability that the next train is on time is 0.8, and therefore the probability is 0.2 that it's not on time. And we can just start building this out. So then we just do the last one. So again, for the last one, if the previous train was on time, then the probability is 0.8 that this train is also on time, and the probability that it's not on time is 0.2. So this is T3. I'm not going to bother writing out. The top one is that it's on time. The bottom one is that it's not on time. So the probability that all 3 are on time so this is going to be equal to 0.9 times 0.8 times 0.8, which equals 0.576. So moving on to part B, and we're told that the 2 p.m. train does not leave on time. So we want to work out the probability that exactly one of the next two trains doesn't leave on time. So let's branch out. So we have our train at 2 p.m. not on time. And we've then got our next train. So this is our train at 3 p.m. on time. Well, we're told that if the previous train is not on time, then the probability that this train leaves on time is 0.65. So therefore the probability that it doesn't leave on time is 0.35. And we can branch out again. So if we go up here, so we only need one of the next two trains not leaving on time. So in fact, give a bit more space. So here we've got our train at 4 p.m. on time. And this is going to be 0.8. And this is going to be 0.2. And not on time. And then because this train did not leave on time, then the next train, the probability this on time is 0.65, and the probability this not is 0.35 again. So then the probability, and I won't bother labeling these last two, mainly because my handwriting is horrible, but I think you get the gist. So the probability that exactly one of the next two trains does not leave on time is the probability that the train at 3 p.m. is on time and the train at 4 p.m. isn't, plus the probability that the train at 3 p.m. is not on time and the train at 4 p.m. is on time. So when we work this out, this is going to be equal to, well, the probability that the train at 3 p.m. is on time, if we go up slightly, is 0.65. And this is going to be times the probability that the train at 4 p.m. is not on time, which is 0.2, plus the probability that the train at 3 p.m. is not on time, which is 0.35, times the probability that the train at 4 p.m. is on time, which is 0.65. So we just need to calculate this value now. And when we do that, we get 0.3575. So moving on to question 21. And we're given the following pair of triangles, and we're told to work out or circle the scale factor of the enlargement. So what I'm going to quickly do here is I'm just going to label the vertices of this triangle. So I'm going to call them A, B, and C. And then I'm going to label the corresponding points on B as well. So we can see that this is going to be point A, and therefore this will be point C, and this will be point B. And we're just trying to work out by what factor the size of this shape has changed. So what we can do is, if we take the height and the width, so if we take the height of the original shape A, so we could say that this is the height of A minus the height of B. So in this case, well, we have a y-coordinate of 5 at A and a y-coordinate of 1 at B. So this is going to have a height of 4. And then for the width, it goes from B to C. So, or rather, it's going to be C minus B. So if we say that this is C minus B, then we have C, which has an x-coordinate of 0, and B, which has an x-coordinate of minus 6. So 0 minus minus 6 is a width of 6. So these are both positive dimensions. If we do the same thing here at B, so let's take the height. If we use the same definition that we use for A, which is the y-coordinate of A minus the y-coordinate of B, then we're going to have minus 4 minus 2, which is going to give us a height of minus 2. So it has a height of minus 2. And then likewise, we've already said that for the width, it was C minus B. So let me just put that in there. So we've already said it's the x-coordinate of C minus the x-coordinate of B. So the x-coordinate of C is 3 and the x-coordinate of B is 6. So it's going to be 3 minus 6, which is minus 3. So if we now compare the widths, so for A, we have a width of 6, and for B, we have a width, let me just write that in, we have a width of minus 3, then we can see that the change here is a factor of minus 2, i.e. if we say A times x equals B, so we have 6x equals minus 3, well, x is going to be minus 3 over 6, which is minus a half. And we can do the same thing for the height as well. So for the height, and in fact I'll write it here, for the height we can say that A has a height of 4 and B has a height of minus 2. Therefore, A times x equals B, 4 times x equals minus 2, and therefore x equals minus 2 over 4, which again is minus a half. So we can see that the scale factor of the enlargement here is going to be minus a half. So moving on to part B, and we're told we want to work out the coordinates of the centre of enlargement. So let me just clean this up a little bit. So what I'm going to do here is we want to draw a straight line between the corresponding vertices. So we want to go for, we want to draw a straight line from A to A, B to B, C to C. So apologies in advance because I know this isn't going to look particularly straight. So now we're going to go from B to B. This is very difficult to draw them exactly at the vertices, but it's good enough. So the coordinates of the centre of enlargement are where all the straight lines meet. So for all intents and purposes, it's at this point here, which we can see has an x-coordinate of 2 and a y-coordinate of minus 1. So it's going to be 2 minus 1 is the centre of enlargement. So moving on to question 22, and we are given the following expression. So we have 2 over x plus 1 plus 7 minus 5x over 3 plus 4 over, oh, sorry, no, ignore me, just plus 4x. And we're asked to write our answer as a single fraction. So what we want to do here, we want to find a common denominator for each term. Once each term has the same denominator, we can then simplify the terms in the numerator. So I'm going to suggest here that the common denominator could be 3 times x plus 1. Now, for this to be the case, let's start with our first term, which is here. If we want the denominator to be 3 times x plus 1, then we can simply multiply the top and the bottom by 3. And we can see that this is actually equivalent to what we had before, because we could just cancel out those 3's, because 3 over 3 is just 1, and we're left with the same fraction. Using the same logic for the second term here, we can times 3 by x plus 1 on the top and the bottom. So I haven't left myself a huge amount of space here. So I'm just going to fill it in up there. And then for the 4x, well, we don't have anything in the denominator, so we're going to multiply top and bottom by 3x plus 1. There we go. So now that we have this, let's just rewrite this out. So we'll just simplify. So we have 6 over 3x plus 1 plus 7 minus 5x times x plus 1 over 3x plus 1 plus 12x times x plus 1 over 3 times x plus 1. So now we can start adding together the terms in the numerator, although the first thing we need to do here is we're going to expand out all the brackets. So we have 6 plus, and then we have 7 minus 5x times x plus 1. So we just need to remember to multiply each term by each other term. So we have 7 times x, which is 7x. Then we have 7 times 1, which is plus 7. Then we have minus 5x times x, which is minus 5x squared. And then we have minus 5x times 1, which is minus 5x. And we're going to expand the brackets out in the final term. So we have 12x times x, so we have plus 12x squared. And then we have 12x times 1, which is plus 12x. And this is all over 3 times x plus 1. And now we can do our last simplification here. So we need to group the number terms, the x terms, and the x squared terms. So let's start with the x squared terms. So we have 5x squared and we have 12x squared. So 12x squared minus 5x squared is 7x squared. Now moving on, let's find out x terms. So we have an x term here, we have an x term here, we have an x term here. So we have 7x minus 5x, which is 2x, plus 12x, so plus 14x. And lastly, we have our number terms. So we have our 6 and our 7. So 6 plus 7 is 13. And this is going to be our final expression. So moving on to question 23. And we're told that Alex makes a bowl for dog food from a solid wooden cone. So you can see here that we have this large cone, of which a smaller cone is then taken. And then from this smaller shape that's left, we have a hemisphere that's taken out. And what we want to know is what the volume of remaining wood that forms the bowl is. So the way we're going to go about this is we're going to start with the volume of the large cone, which has a radius of 9 centimeters. Then we're going to subtract the volume of the smaller cone, which has a radius of 6 centimeters. And then we're going to subtract the volume of the hemisphere. And that will give us the total volume of wood that makes the bowl. So let's just go over some notation here. So I'm going to say V sub BC is the volume of the big cone. The SC is the volume of the small cone. Then we have VHS, this is the volume of the hemisphere. And VB, which is the volume of the bowl. And so what we can say is the volume of the bowl equals the volume of the big cone minus the volume of the small cone minus the volume of the hemisphere. And we're given two pieces of information here. So we have the volume of a cone is equal to 1/3 pi r squared h, where r is the radius and h is the height. And we have the volume of a hemisphere is equal to 2/3 pi r cubed, where r is the radius of the sphere. So let's just draw out our problem here. So we have this large cone, and we've got a radius here of 9 centimeters. And then we have this smaller cone, and this has a radius of 6 centimeters, and we have a height of 30 centimeters of the total thing. Okay, and then I'm just going to call this height here little h. So this is the height of the small cone. So what do we know so far? Well, for the big cone, we know the volume is 1/3 pi r squared. Do we have r here? Well, we do, because r squared here is going to be 9 centimeters. So it's going to be 1/3 pi times 9 centimeters squared times h, which is the height, which we've been told is 30 centimeters. So we can work this out, and we get that this is equal to 810 pi. Now, can we do the same for the small cone? Well, we have 1/3 pi times the radius, which is 6 centimeters squared. But here, we don't know what h is. So we're going to have to find h to go any further. Lastly, we have the volume of the hemisphere, which is 2/3 pi, and then it's going to be r cubed. So in this case, r is going to be 6 centimeters. And when we work this through, this gives us 144 pi. So now what we need to do is we need to work out this small h, and then we can find our final answer. Now, the way I want you to think about this is, if we take a right angled triangle, or part of a cone, so it's a little subsection of a cone, imagine. So we've got a right angle here, we've got an angle which I'm going to call theta, and we have our height h, so this is going to be the height of the small cone, and we have our radius r. So what we want to do here is work out the relationship between h and r, because if we can work out this relationship, then if we know the radius of the small cone is 6, then we might be able to work out what the height of the small cone is. So what we can say here is, if we remember our basic trigonometry, we have this side h, that's the adjacent side, and this radius is our opposite side. So if we remember SOHCAHTOA, so tan theta equals opposite over adjacent, which equals, well, the opposite side is the radius, and the adjacent side is the height. Now, the key thing to notice is this angle theta is the same regardless of if we take the small cone or the large cone, because I could extend this and you see that the angle remains the same, which means if we were to then call this long length big H and this longer length along the bottom big R, i.e. the height and the radius of the big cone, well, what we're saying here is that tan theta equals opposite over adjacent, which is this radius over the height, but it's true for any radius or any height as long as it's the same angle. So this is equal to big R over big H. Now, we know little r, we know that little r is 6 centimeters, we know that big R is 9 centimeters, and we know that big H is 30 centimeters. So what we can do now is we can work out small h by rearranging this. So we have we have little r over little h is equal to big R over big H. So the ratio is the same between the two. So if we just rearrange this, so if we move that little h to the right-hand side, we get that h is equal to r times big H over big R, which means little h is equal to 6 centimetres times 30 centimetres over 9 centimetres. And when we work this out, this gives us 20 centimetres for small h. So now we have everything to work out the final volume here. So if we go back to our volume of the small cone, we're going to have 1/3 pi times 6 centimetres squared times h, which we know now is 20 centimetres. So if we plug this into our calculator, we get that the volume of the small cone is 240 pi. So going back to the volume of the bowl, we've said that the volume of the big cone is 810 pi. And from this, we subtract the volume of the small cone, which is 240 pi, and we subtract the volume of the hemisphere, which is 144 pi. And this gives us a value of 426 pi, and let's just remember our units, which are centimetres cubed, as this is a volume. Moving on to question 24. And we're told that on the same day, Kate buys a car for £14,000 and a painting for £5,000. We're told the value of the car decreases by 35% in the first year and then by 10% each year, and the value of the painting increases by 4% each year. So we want to know, after 5 years, does the painting become worth more than the car? So what we need to do here, let's just write out, we've got our car, which starts off at £14,000. We have our painting, which starts off at £5,000. And we want to know, what's the state of play after 5 years? So if we take the car first, we've got £14,000, and we're going to multiply this. Well, so it decreases by 35% in the first year. This is the same as multiplying it by 0.65. And then after the first year, it decreases by 10% each year, which is the same as multiplying it by 0.9. I mean, it's 0.9 4 years running, so it's going to be 0.9 to the power of 4. Likewise, for the painting, it starts off at £5,000, and it increases by 4% each year, which is the same as multiplying this by 1.04, and it's over 5 years, so it's to the power of 5. So working this through, for the car, this is going to be equal to 5,970.51. For the painting, it's going to be equal to 6,083.26. So we can see here that the painting is in fact worth more than the car. So moving on to question 25, and we're given this triangle here, which we're told has an angle here of 110 degrees. On this side, we have a length of 13.6 centimetres, and on the other side, we have a length of 7.2 centimetres. And we're asked to work out the upper bound for the area of the triangle. So what I'm going to do, let's call these sides A, B, and C, and then the angle is opposite the length, so this would be angle C, this would be angle B, and this would be angle A. Now the area of a triangle is given by half A, B, and then the sine of C. So looking at this equation, we can see that these two lengths A and B, to work out the upper bound, we're going to need to round these up. So A is going to become 7.25 centimetres, and B becomes 13.65 centimetres. Now, the tricky bit that we need to work out here is, do we need C to be rounded down or rounded up? Well, let's just have a look at a sine graph. So let's just put our points. So we've got 90 degrees here, we've got 180 degrees here, 270 and 360. So if we plot our points here, so these are our inputs, so these are our x. So at 0 degrees, then the sine of 0 is 0. The sine of 90 degrees is 1. The sine of 180 is 0. The sine of 270 is -1, and the sine of 360 is 0. So let's just plot this. So what we can see here is for this region, i.e. between 90 and 180, which is where 110 degrees sits, if we were to plot roughly to here, let's say this is 110 degrees here, we can see that if we increase, so as we go in the direction along the positive x-axis, we can see that the value of sine, so we have sine of x on this axis, we can see the value of sine of x at 90 degrees it's 1, but it progressively becomes lower as we increase the angle to 180. So actually, for the biggest value of sine of x, we need the smaller value of the angle. So what we want to do here for the angle C, we want to round down. So we'll round down to 109.5 degrees. So I'm just going to call this the area equals a half. And we've said A in this case is 7.25 centimeters times B, which we said is 13.65 centimeters, times the sine of C, and we've said that C is 109.5 degrees. And when we work this out to one decimal place, we get 46.6, and it's going to be centimeters squared. So moving on to question 26, and here we can see we have this exponential graph y equals 5 to the power of x. So in part A, we're asked to sketch the graph of y equals -5 to the power of x. Well, in this case, putting this minus sign in front of our original function is just going to flip this about the x-axis. So for whatever value of y we had initially, we now just have the minus equivalent, don't we? So before, if we had x equals 0, we would have y equals 5 to the power of 0, which is just 1. So now, in this case, when x equals 0, we're going to have y equals minus 5 to the power of 0, which is just going to be -1. So for each value, this is going to be the same. So the final line is just going to be a reflection about the x-axis. And moving on to part B, we want to sketch the graph of y equals 5 to the power of x minus 1. So if we just consider some key landmarks here, so if we have x equals 0, then 5 to the power of x, which is what we initially had, was 1. But now, when x equals 0, 5 to the power of x minus 1 is 0. So we have a key landmark here. And then if we think about it, as x tends towards negative infinity, i.e. goes infinitely in that direction, y equals 5 to the power of minus infinity, which equals 1 over 5 to the power of infinity. Well, anything to the power of infinity is infinity. So we have 1 over infinity, which is just going to be 0, so it tends to 0. But in the case that we have 5 to the power of x minus 1, so we have 5 to the power of minus infinity minus 1, then x is going to tend to -1. And in the case, that x tends to x tends to infinity, then we have 5 to the power of infinity, a very terrible infinity sign, equals infinity. Therefore, for the case of 5 to the power of infinity minus 1, it's still just going to tend to infinity. So in this case, what we have is going to be something that looks roughly like this. So thanks for watching, guys. Hopefully you found that useful. If you have any questions or even just feedback for how this could be more helpful, leave a comment and I'll get back to you as soon as possible. If you haven't already, hit that like button and subscribe to our channel. As I said at the start, this really will help us grow, so your support is really appreciated. With that said, all the best, guys, and I'll see you at the next one.